Technology is developing at an increasingly rapid pace. In my lifetime, I've already witnessed computers evolve from the bulky Macintosh desktops that had little use other than drawing scribbles on paint and saving Word documents to floppy disks, to powerful machines that perform impressive calculations on increasing numbers of shrinking transistors and can access vast quantities of information from the internet. Today's possibilities were unimaginable 2 decades ago. Imagine what we will achieve in the next. Imagine if one day we could simulate the human brain, the most complex system in our universe. This is what artificial intelligence is making progress towards, with the cognitive power of machines snowballing. AI can understand and learn from data using neural networks that, like the human brain, consist of interconnected nodes in a highly parallelized system. AI is already ingrained in our society. With facial recognition, spookily accurate personalized ads, and the ability to signal a pandemic from social media posts, just a few examples. AI's impressive progress to date led venture capitalist and AI oracle Kai-Fu Lee in 2019 to predict that 40% of the world's jobs would be taken over by AI in 15 years. However, the version of AI that we experience today is known as general AI, as it is only optimized to perform a few specific tasks. If AI is to have the creativity needed to outperform humans on all fronts, we need a general form of AI that can operate in a wide range of environments and learn new skills. No one knows when a general form of AI will arrive. Opinions vary wildly. Where tech guru Elon Musk thinks that AI might be knocking on our door tomorrow, machine learning guru Andrew Ng thinks that worrying about superhuman intelligence today is like worrying about overpopulation on Mars. And in fact, the average prediction from AI experts as to when general AI will arrive isn't until 2062, and many are skeptical that it will even arrive this century. There is a flaw in their reasoning. These predictions are heavily based off a knowledge of the progress of classical computers. My research as a quantum physicist involves developing an entirely different kind of computer that will throw current predictions out of the window. We are at the brink of a technological revolution where we'll be able to harness the laws of quantum mechanics that rules in the land of the unimaginably small for our advantage. Whereas classical computers store information in bits that exist as a 0 or a 1, quantum bits, more famously known as qubits, however, can exist in a superposition of both 0 and 1 at the same time, like how Schrödinger's infamous cat can be thought of as being dead and alive at the same time. This enables qubits to store more information than their classical counterparts. The real power of quantum computing kicks in when you can entangle many qubits together using non-local interactions. When you double the number of bits in a classical computer, you simply double its processing power. However, thanks to entanglement, when we add additional qubits to our quantum computer, we increase its power exponentially. In order to build a qubit, we just need a quantum system with 2 or more energy levels. And for this, there are many ways to skin Schrödinger's cat, so to say. Whereas Google uses superconducting loops that encode the 0 or 1 in current flowing clockwise or anti-clockwise, my research uses the spin of an electron bound to a single atom in silicon that is either 0 or 1 when its spin is up or down in a magnetic field. This method shrinks qubits down to the size of atoms, enabling arrays of millions of qubits to be routinely placed using ion implantation that shows great promise for scalability. Only time will tell which hardware platform will take the lead in the space race for the commercialization of quantum computing. The incentive is huge. Quantum algorithms can solve certain problems exponentially faster than their classical counterparts. This will not only speed up problem solving, but open the floodgates to being able to solve problems that are currently intractable with our classical computers. For example, in 2019, Google's quantum computer with 53 qubits solved a simulation problem in just 200 seconds that they predicted would have taken the fastest classical supercomputer 10,000 years to solve. That's over 1 billion times faster. The subset of problems that quantum computers will be able to solve is only going to grow from here, as heavyweight companies compete head-to-head to increase the number and fidelity of their qubits. The future potential for quantum computing is vast, with applications ranging from drug discovery to being able to harness clean energy by inventing novel ways to allow for nuclear fusion reactions. Quantum computers have the potential to supercharge our progress towards AI by efficiently solving linear equations simultaneously. This is the crux of machine learning algorithms that continuously improve their models by input data and experience. Like how an electron should be considered as a cloud of probability filling all space at the same time, a quantum algorithm would be able to process the entire complex data set required to train a machine learning model, drastically speeding up this process. If quantum computers can drastically increase the speed and power of neural networks, the artificial brain may reach general or even superhuman intelligence sooner than we think is possible. As with any technological development, general AI could be used as an asset or a threat. However, this time we are dealing with something that has the power to make humanity obsolete. AI could lead to a technological utopia if we can evenly distribute the benefits gained from it in wealth and knowledge. Or we could end up increasing the gap between the elite that harness AI for their desires and the rest of us that find the availability of jobs increasingly scarce. In healthcare, AI could revolutionize the diagnosis of diseases. But as a byproduct, we might be denied jobs and health insurance for an underlying condition that we weren't even aware of. Infinitely more sinister than general AI is superhuman AI. If we reach the singularity, where the intelligence of machines surpasses that of humans, we won't be able to control or predict its next move, as intelligent algorithms will be able to improve themselves as they reproduce with no input from humans required. This isn't something we could undo. There would be no Control Z, as the ability for AI to outsmart and therefore control humans would spread like a virus throughout the veins of the internet. With the singularity, we are like children playing with a nuclear bomb. How can we safeguard our future to ensure that we thrive in the 21st century? For this, I see 3 things that require urgent attention. 1. Control the reaches of AI while it is in its development. We need to decide whether we choose to prevent the singularity entirely such that humans will always have the upper hand, or to welcome it if we ensure that the AI has values aligned with ourselves, such that we would be happy for it to operate autonomously. For this, we need to define boundary conditions for which AI can operate in as specifically as possible, being careful to anticipate any loopholes and having in place fail-safe mechanisms. In the early days of nuclear physics, after Rutherford discovered the nucleus, the scientists were not aware that they needed to have regulations for nuclear weapons. We need to learn from history to avoid disastrous consequences. 2. Compete with AI for longer once it starts to gain the competitive edge over humans for certain tasks. For this, our workforce needs to redistribute and carve out new jobs in this changing environment. I predict that the average human will have to hold more jobs in different disciplines throughout their lifetime. For this, we need more emphasis on continued learning. 3. Accept the inevitable takeover of AI and learn to flourish amongst it. We need to have a strict AI tax such that its wealth could be distributed fairly and allow for a universal basic income. With the extra time and energy that will be freed up from mundane tasks, we can channel this into our passions and committing charitable work that could range from helping our neighbour to solving the climate crisis. Will we be prepared for this before a researcher like myself manages to build a full-scale quantum computer that could speed up progress towards superhuman AI? The quantum future is approaching faster than we think. We need to choose before this whether AI will liberate or enslave humankind.